Factor each of the following. To factor a polynomial expression, always first factor out any GCF, or greatest common factor. In order to factor a trinomial of the form ax squared plus bx plus c, where a does not equal 1, we're looking for two numbers. I'll call them p and q, such that p plus q equals b. This is the coefficient beside the x. And p times q equals a times c, the coefficient beside the x squared, times the constant term. If these numbers exist, then we will rewrite the bx term as px plus qx. If these numbers do not exist, then the trinomial cannot be factored. We'll then first factor the two terms, ax squared plus px, and the last two terms, the qx plus c, separately. This should result in a common binomial factor. We'll then combine the factors that are multiplied by the common binomial factor. For the first trinomial, note that there is a common factor of 4. So we'll factor that 4 out, leaving us with 6a squared plus 7a minus 10. We're then looking for numbers that multiply to give negative 60. This comes from the 6 times negative 10. And add to give 7, the coefficient beside the a. These numbers are 12 and negative 5. We'll then rewrite that trinomial, breaking up the 7a to 12a minus 5a. Noticing the 6a squared plus 12a, we can factor out a common factor there of 6a. Note the 4 that we had originally factored out has to remain. We then look at the minus 5a minus 10. From there, we can factor out a negative 5. And note here that we also obtain an a plus 2. The a plus 2 then is a common binomial factor multiplied by both the 6a and the minus 5. We can then combine the 6a and the minus 5 into a second binomial factor, giving us our final factored form, 4 times a plus 2 times 6a minus 5. For the second example here, again, we have to factor out any GCF. In this case, the GCF is 2a and x plus 3. This leaves inside the square brackets 6 x plus 3 squared plus 11 times x plus 3 minus 10. Here, relative to the ax squared plus bx plus c, the x has been replaced with x plus 3. I will use a u substitution, u equals x plus 3, to simplify the expression and make it a little bit easier to factor. I then have 2au times 6u squared plus 11u minus 10. Here I'm looking for numbers that multiply to give negative 60 and add to give 11. In this case, those numbers are 15 and negative 4. In this case, I'm going to do a different method to factor. What we can do is simply write the factors as 6u plus 15 times 6u minus 4, simply using the 15 and the minus 4 that multiplied to negative 60 and added to 11. Note, however, that we will not want 6u and 6u as the leading terms in the binomials. Multiplying these would give us 36u squared instead of 6u squared, which is what we have in the trinomial. We will then have to divide these binomials by a total of 6. In this particular case, we can divide 6u plus 15 by 3 and 6u minus 4 by 2. This gives then the result 2au. We have to leave that initial greatest common factor out in front. We then have 2u plus 5 times 3u minus 2. We can then substitute x plus 3 back in place of u. We then have 2a times x plus 3. Inside then the square brackets, we have 2 times x plus 3 plus 5, and then 3 times x plus 3 minus 2. Note here, though, that inside these square brackets, we can simplify those expressions. Inside the first set of square brackets, we can multiply 2 times x plus 3, giving us 2x plus 6, and then that 6 added on to the plus 5 gives us 11. For the second set of square brackets, 3 times x plus 3 gives us 3x plus 9, and then 9 minus 2 gives us the plus 7. We then have our final factored form, 2a times x plus 3 times 2x plus 11 times 3x plus 7.